Welcome back to All This Math. This is Professor Parker. If you're here, hit the like button. I want to thank all of you that have already subscribed. But if you haven't subscribed, go ahead and hit the subscribe button. As I'm doing my explanation of this video we're about to get into, please, if you have any questions, put your questions in the comment section. All right. And when we're done, share this video with at least 2 people. All right. Now, what are we doing today? Oh, and by the way, yeah, shout out to the ancestor Thomas Sankara, leader from West Africa, specifically in Burkina Faso, leader of the Burkinabe Revolution, which was from 1983 to 1987. Unfortunately, assassinated in 1987 by European forces. Did a lot to push forth the program of Pan-African nationalism, and his work is not done. If we look at what Ibrahim Traore is attempting to do now, also in Burkina Faso and West Africa, we see that the tradition is being carried on. So definitely do your research on Thomas Sankara if you're unfamiliar with this brother. All right, now we're gonna do a subtraction problem. 4,260 minus 2,357. 4,260 is what we call the minuend, M-I-N-U-E-N-D, M-I-N-U-E-N-D. And 2,357 is what we call the subtrahend. Now, we're going to do this problem in 2 different ways because it's very important to me, for you all watching this, to know how to do problems in multiple ways and have options, because options are powerful, right? Having options is powerful. You don't want to be just committed to just only one way of doing things. Even if you prefer that one way, at least you also may know other ways that you may at times have the option to experiment with. So what we're going to do is first what I call the left to right method, right? The left to right method. Now, the left to right method is a little unorthodox, right? You start at the left of the problem and you just subtract the individual digits, right? And negative values are okay. Negative differences are okay. So that means you don't have to borrow or regroup anything, even though I think it's important for you to know how to borrow and regroup. Using this method, you don't need to borrow nothing. So we can end up with negative values. So let's get into it. First, start in the thousands place with the 4 and the 2. So what's 4 minus 2? Positive 2. So you just write the 2 down. All right, nothing too crazy about that. But when you go to the hundreds place, you're doing 2 minus 3. Now, 2 minus 3 is negative 1. All right, we have to understand how to add and subtract positive and negative numbers when we end up, especially when we end up with negative differences. So 2 minus 3 is negative 1. So you would write a 1, and some people like to put the vertical bar on top to show the negative. So let's just do that for now. So this is a negative 1. Then we go to the tens place. We got 6 minus 5. 6 minus 5 is positive 1. And then we go to the ones place. We got 0 take away 7, or 0 minus 7. 0 minus 7 is negative 7. So you put the 7 here. Boom. Now, how do you get to the answer, though, right? Because this looks crazy, right? You expand it in terms of place value. So I got 2,000. This is a negative 100. So that's 2,000 minus 100. 2,000 minus 100. This is a positive 10. This positive 1 represents a positive 10. So now I started 2,000. I subtract 100, right? Then I add 1. Actually, no, I'm not adding 1. That's wrong. I'm adding 10. This is how many 10s I got. This is 1 10. This is a 10, a single 10. So then I add 10. But then I subtract 7, right? Because this is in the ones place now. So what does that look like? That looks like this. It looks like in expanded form, 2,000 minus 100. Why am I subtracting 100? Because this is a negative 1. And that's how many hundreds I have. I have negative 100s. Because in the hundreds place, I did 2 minus 3, which gave me negative 1. Then I do plus 10. Why? Because in my tens place, I got a positive 1. 6 minus 5 is positive 1. So I got one group of tens. Then in my ones place, I got negative 7. So I'm going to subtract 7. Now, what do we end up with when we do all that? If you start with 2,000, imagine if you're a parent watching this, parent, grandparent, uncle, auntie, whoever, you start out with $2,000. Then you spend $100. That money is subtracted. Now you end up with $1,900. Then you got $1,900 plus 10 is $1,910. You get 10 more dollars added to your account. $1,910. Then you take away 7. That leaves you with $1,903. 1,903. That's the final answer, 1,903. Now, let's do it another way, called the combined differences method. All right, so in this video, you're getting a 2 for 1. All right, so I'm going to rewrite the problem. Actually, no, we start with the minuend. I'm going to write it up here, and I'm going to switch colors too. Asada recommended I use the black cherry marker from time to time. You know what I'm saying? That's my daughter Asada. You'll see her on here a lot of the videos if you're unfamiliar. All right, so 4,260. We start with the minuend. Now our goal is to get to the subtrahend. But what we do is we create a series of smaller subtraction problems that should be easier to work with by using numbers that end in zero. Let me give you an example. So I might say, okay, well, what's 4,260 minus 4,200? Right? And then I do that subtraction because I could do that mentally, kind of easy. 4,260 minus 4,200 is just 60. So I write that over there. Now my goal is to get to this number. This is my subtrahend. I'm trying to get to this number, right? And then I'm gonna take all the differences and add them up. And then that sum of the differences, the combined differences, is going to be my difference between these two numbers. All right. So then now let's say I go down to 4,000. Let's jump down to 4,000. Now, why did I pick 4,000? Because it's a number that ends in a bunch of zeros. So it makes the subtraction easy. Again, this is about efficiency and ease. All right. So then I say, okay, well, the difference is 200. Difference between these two is 200. All right. Now the next thing I'm gonna do, I'm gonna go down to 3,000. Why? Because it ends in zeros. Now, is that the only option? No. With this method, you have options. We have options. You could pick different numbers, whatever's easy for you. This makes sense for me. So 4,000 minus 3,000 is going to be 1,000. All right. Now, again, I'm trying to get to 2357. So what I'm going to do is I'm going to go from 3,000, I'm going to go down to 2,400. I'm going to go to 2,400. And the difference between 3,000 and 2,400 is 600. So I put the 600 right here. All right. Now I'm trying to get to 2357. I'm going to go from 2,400 to a number that ends in zero, 2360. 2360. Why 2360? Because that's greater than 2357. It's greater than 2357 and it ends in a zero. It's greater than 2357 and it ends in a zero. And the math is relatively easy. 2,400 minus 2360 is going to be 40. 40. And then last but not least, I'm going from 2360 to my subtrahend. And then I'm going to have 2357. And then 60 minus 57 is 3. Now, to combine the differences means to add the differences. To combine these differences, because the differences between these pairs of numbers can be added up and it will equal the result. It will equal the difference between this number and that number. This number and that, which should make sense because the difference between this number and that number consists of all of these smaller differences combined. All right. So the way I add the numbers up mentally is I start with the biggest number. That's what I do. I start with the biggest number. So I'm gonna start with 1,000, right? And then I'm gonna add 600 and 200. That's 1,800. All right. So 1,000, 600 is 1,600 plus 200 is 1,800. 1,800 plus 60 is 18. 60 plus 40 is 1,900. 1,900 plus 3 is 1,903. We get the same answer. So this is like a system of checks and balances. It's a way to check our work. Do the problem in two different ways. Do it in two different ways. See if you get the same answer. Hopefully you ain't make a mistake in both ways. You know what I'm saying? But usually, typically, you'll have the same answer, or the answer will be correct if you get the same answer doing the problem in two different ways. All right. Now, why is 1,903 significant? Well, for one reason, 1,903 is the birth year of Ella Baker. Ella Baker. Ella Baker. Civil rights activist, human rights activist, responsible for organizing the Student Nonviolent Coordinating Committee, which was an organization led by youth, college students for the most part, the likes of Kwame Ture before he became Kwame Ture, when he was still Stokely Carmichael, Marimba Ani before she became Marimba Ani, when she was Donna Richards, Bob Moses, Cleveland Sellers. Who else? What's the brother's name? Charles Cobb. How could I forget Charles Cobb? Charles Cobb co-authored Radical Equations with Bob Moses. Also wrote the book That Nonviolent Stuff Will Get You Killed, right? Talking about, the use of, strategic violence during the civil rights movement, even though they don't want to teach us about that in school. They want to act like black people didn't have guns back in the day. We always had guns, right? But a lot of people, were involved with NSNCC. Marion Barry, former mayor of Washington, D.C., right? Marion Barry was in SNCC, right? A lot of these people, a lot of solid men and women was in SNCC, and Ella Baker, right, was the person who came up with the idea for SNCCs and helped to organize SNCC, right? She wasn't the leader of SNCC, but she didn't want to be the leader of SNCC. She wanted it to be an organization led by youth, all right? And they were able to make many advancements and push, push this country to, in certain ways, to be able to, embrace the humanity of people of African descent in the United States of America. So this is a book about her. This is a biography entitled Ella Baker and the Black Freedom Movement, A Radical Democratic Vision. I'm not too sure about that, if I would characterize it that way, but at any rate, it is what it is. Written by Barbara Ransby. All right. So if you're interested in more information on Ella Baker, this is, a source of some information. But she was born in 1903. So this is also a way, through the hystematics approach, where we create math problems intentionally with the goal of ending up with a number that has some historical significance. All right. So make sure you hit the like button if you didn't already. Subscribe if you're not already subscribed. If you got any questions about anything I did with these two methods, with the left to right method or the combined differences method, please put your question in the comments, and please share this video with 2 people. All right. Peace.